This is number 3 in my series entitled What Makes It Work? And in this video, this topic will be, how does a two-cycle, two-stroke engine work? In the last video, I covered how does a four-cycle engine work. So if you haven't seen that, take a look at it. But what I'm going to do here is to show you, first of all, some different models that I have of two-stroke engines. And this is a Power Products. They're really both the same, but this one is missing the gas tank and a few other parts. But this will be the sacrificial one that I cut apart and take apart to show you the inner workings. But before we get to that, let me just show you a few other two-cycle engines that I have. I've had a love for these little Power Products engines ever since I was a boy, because my neighbor Phil Blott had one of these on a cart that they made. And I fell in love with it then, so I got 4 of them. So here's 2 others. I'm in the other garage, and they're kind of set up the same way. One's missing the gas tank, and one's got the gas tank. So I got plenty of those, and I need to get a couple of them running, but I've already had these at least 10 years and didn't get around to them. But underneath the bench is my Vespa engine. I'm not going to talk about that. That was shown in one of my Vespa videos, but there's a Vespa engine, and that of course is a two-cycle engine. That was made back in mid-50s. Hope to get it running someday. I'm over on the other side of the garage, and here's some other examples of two-stroke engines. These old Maytags were all two-stroke. Here's the single-cylinder model and the twin, like you see Shop Dog Sam working on all the time, and I got about 3 more of those as well. And remember that virtually every chainsaw and blower ever made is a two-stroke engine, and they're little throwaway engines that really aren't repairable, and they make them by the millions. They're cheap to make. Here's a little two-stroke engine that's on my 2-wheel scooter that my granddaughter loves to drive. Sophia considers this hers. Runs pretty good too. I really don't know why I have all of these small engines, but got a whole rack of them here, but I'm really talking about two-strokes. And the Jacobson engines from years ago were all two-stroke, and they had these at the hardware store when I was a kid. 16, worked there, and I used to work on the Jacobsons, and without any training either, by the way. We just dug in and fixed them. Remember, the two-stroke engines normally have the spark plug on one end and the carburetor on the other end. That's one way of identifying them as a two-stroke, because it normally doesn't say anything on them other than to mix the oil with the fuel. Also, have you noticed that in the stores now they're selling pre-mixed fuel in a quart can around the chainsaws, and you will pay dearly for it, but it saves people from mixing, especially single women. I'm on my bicycle and I'm taking a field trip to take a look at a two-cycle car, a two-stroke engine car, and here's that little beauty. Let me get off my bicycle here, which isn't an easy job for an old shop teacher. But this is a Saab, probably from the 60s. Kind of rough shape. But they had a two-cycle engine. There's a little beauty. My buddy had one of these. I don't know what possessed him to buy it, but I do know they had to replace the engine shortly after he had moved to Oregon. Is everyone in the world mowing their yard today? Any desire to own this thing? Could it have been considered good looking when it was built? Let's have a nice side view of it. There's an old Ford V8 right next to it, and my leg's getting torn up by a raspberry bush. But there's that little beauty. And yes, it is 3 cylinders. Can you see the 3 spark plugs? And then there was a place under here, I think, where you put the oil, but I don't remember where. It'll never run again. 5-speed transmission. Did you like the little field trip? Here's the question of the day. What is the make and model of this car? Let's take a look at some of the characteristics of a 2-stroke or 2-cycle engine. Number 1, they're lightweight and generally small in size. 2, they have fewer parts, so they're cheaper to make. 3, there's no oil in the crankcase. 4, all the lubrication is by oil that is mixed with the fuel. 5, a power stroke in every revolution rather than every other revolution like a 4-stroke. They are capable and often run at higher speeds than a 4-cycle. 7, they can operate in any position depending on the carburetor and the fuel tank. In other words, it cannot be a float type of carburetor, and fuel must be available. And a good example of that is a chainsaw that can run in almost any direction position. You cannot do that with a 4-cycle because the oil will be deprived. Usually very rapid acceleration when you hit the throttle. 9, they're easy to start in the winter because there's no thick oil in the crankcase, so they're often used in snowblowers and snowmobiles. And 10, they can be made reversible, such as in a Fairmont engine. That's just usually by changing the ignition timing. Here's some of the cons for a 2-stroke engine, and there might be more, but generally the fuel mixing is messy and it's a nuisance. 2, they will self-destruct without oil in the fuel, and I've seen it happen. I watched my neighbor mowing his yard with a lawnmower, and he did not have the correct oil in the fuel, and it just suddenly stopped, and he cursed himself. They're smoky. They used to be a lot more smoky than what they are right now as far as the amount of oil mixed with the fuel, but that was generally pretty objectionable. And they are big polluters because there's quite a bit of raw fuel that gets dumped out. Therefore, the EPA hates them. But then again, the EPA hates all engines, and they would have us riding bicycles if they had a chance. However, their bureaucrats would be riding around in big fat SUVs. Here are some popular applications for 2-stroke engines. You see them in chainsaws, string trimmers, outboard motors. Now there's a trend toward 4 cycles, but at one time they were all 2-cycle. Snowmobiles, watercraft, motorcycles, yard blowers, some mowers, not so much anymore, but there were certain brands such as those made by OMC, namely Lawn Boy, and snow blowers because they were easy to start in the winter. Okay, back to this little Power Products engine, and these were made by Lawson, Tecumseh, Power Products, Peerless. It was all the same company out of Wisconsin. And this particular one made in Grafton, Wisconsin. My Uncle John worked in Grafton at the Badger Worsted Mills. My grandmother lived in Cedarburg, Wisconsin, so we often visited Grafton. But looking at this little mower here, or motor that I'm going to take apart, actually engine, sometimes I use the word motor, that is incorrect, but I like the design on these. And one stroke of genius that I just am amazed at here is that it's a 2-piece gas tank. So if the gas got fouled or you needed to clean it, you just took the top off and you could clean it. Oh, how I wish that my Vespa gas tank was constructed as such. But you'll also see this is, of course, air-cooled, and there's a all kinds of baffles on here to direct the air. The governor is under here, and as I told you earlier, typically on a two-cycle, you got the head on one end and you got the carburetor on the other end, because the fuel always enters into the crankcase. There are no valves. The piston itself, in a way, acts like valves. However, there are reed valves right in here, which we'll take apart and show you, and that just, well, I'll talk about that later, but it's nothing like the valves in a four-stroke engine. But this is not the one I'm going to take apart, because I want to restore this one, which may not take much, I'm not sure. This is the familiar logo of Tecumseh, and of course they owned Lawson. I don't believe that name is used anymore, nor is Power Products, but they were pretty popular at the time, and this engine is probably from the 50s. There were 4 screws holding the cover on. That's cast aluminum. I think that's really neat. Got a little bit of a defect there in the casting. Even a arrow indicating the direction of rotation, and there's the logo, and this is a model 150. Now this will direct the air from the fan on the flywheel over here, and the air would come in here and exit here across the fins on the cylinder, right through there and across the head. And by the way, this is a headless engine. That is, the head won't come off. It's all one casting. And you can see the direction of the fins on the head align with the way the air is going to go. This is the muffler, which I'll take off here presently, and the magneto is inside the flywheel. I don't believe I'm going to take that off. Well, I may need to, but at this point I tentatively do not intend to. And here's the kill button, governor, carburetor. I did clean this up real well. It was filthy dirty, but it almost looks like new right now. And look at that nice little base, and that's a separate piece also. This is going to be a long video. I didn't mean for it to be this long, but I'm getting carried away. I'm removing the muffler, and you can see that's all cast. Kind of interesting, held on by 2 screws, flathead screws. Now this is the governor cover, so I'll take that off. And inside is a little centrifugal governor that just operates by centrifugal force, and this little lever rubs against it. This is brass, and in turn controls the carburetor. The purpose of a governor is to maintain a constant speed regardless of the load. On a 2-cycle engine, the case back here must be absolutely airtight. If there's a bad gasket or a little hole or something, it just isn't going to operate correctly, and it'll lack power because it's sucking air into there, and that can be checked with propane if you know what I'm talking about. I'm not going to get into that, but I hope to get the cylinder off now. And I've removed 4 nuts, and this is the cylinder, sometimes called the jug, so I'm going to tap it. There's a gasket right here. And if I was going to put this back together, oh, that came right loose. See if it comes off. Might need just a little finessing to get it off. The cylinder pulled right off. And we'll talk about all of this here in a few minutes. But interestingly enough, on the cover here, among other things, and it tells you how much oil, takes a half a pint of oil per gallon. That was pretty common back then in the motor scooters and things that I had. But at the bottom here it says, remove carbon from muffler and exhaust holes every 50 hours. And you can see, or maybe you can't, that this is what they're talking about here. If I can get my light in there. We need to remove the carbon. Can you see how it's built up in there? Those are the exhaust ports. The piston is 1 3/4 in diameter. This is really a small engine, and I suspect this is only about a half horse. I really don't know. There are 2 rings, compression rings, because there is no need for an oil ring, because there is no oil in the crankcase. Quite a bit of scuffing on the piston. Matter of fact, the piston doesn't look good at all right here. And I'm going to talk about the shape of this piston dome, which is a necessary shape for cross scavenging, which I'll talk about in a minute. I've opened this cover just to show you that this is just an access cover, and this is the transfer port. So you're looking into the transfer port, and there are exhaust ports on the opposite side here. But in a cross-scavenged 2-cycle engine, these ports are exactly across from one another, as indicated by this rod. Possibly a little bit of an angle, but pretty much straight across from one another. And as far as the bore is concerned, if I can look in there, see what kind of condition that's in. Yeah, there's some scuffing and scraping in there. It's not the best, but probably would clean up a little bit with a hone and be perfectly serviceable. I have removed the rings, and the ring grooves are incredibly clogged with carbon, so they needed to be cleaned. And it's easy to get the rings off without breaking them if you're careful, but they are delicate. And also interesting to note that the connecting rod is made of brass. I'd say that's very unusual. Carburetor comes off with just 2 nuts on those studs, and it's a little Tillotson carburetor. They were pretty common. I believe it's a float type. Throttle, fuel inlet, choke, fuel shut-off, air cleaner, and I don't know if that's, it must be the main needle valve, and it's got a series of numbers on there. I can't quite read it without cleaning it up. Nice little assembly, all aluminum. It's not the purpose of this video to talk about carburetors, but right behind the carburetor and on the same 2 studs is the reed plate, and these are little reed valves, one-way valves just made of spring steel, and there's 4 of them, and that allows the fuel to go in with suction. That is, this way. Those gets sucked open, and then when the crankcase gets pressurized, they slam shut so that the fuel mixture can't go back out. So those are the valves that are in a 2-cycle engine. Not all of them operate this way, but some have rotary, what they call little rotary valves, but these are reed valves, and that's the reed plate. Pretty precision, and that's in perfect shape. When the piston goes back, it pressurizes the crankcase just a little bit, and then it forces that charge through the transfer port and through these ports up. Yeah, looking into the cylinder is very carboned up, and that would need to be cleaned. See what's coming out of there, and there'd be a lot more. And looking back into these exhaust ports here, one is totally clogged. See, there's a big one in the middle, there's one here, and then the other one is clogged. That'll require a little digging, but looking at it from here, you see there's 3 of them. and there was no exhaust at all coming out of that one. So there would have been quite a restriction. Interesting to look at some of these parts and what is wrong and what is right and how it works. In my previous video on 4-cycle engines, I was pondering how to make the cutaway. And this engine is constructed a little bit different, but there, right on the cover of this Goodhart-Wilcox publication called Small Gas Engines, written by Alfred Roth, there's a cutaway. What a great idea. That's how it should be done, but this was the kind of engine, in fact, that I was looking for that had the side cover. That's why I was working on that Clinton engine. Then inside here, there's a vertical engine that's cut away professionally, so that's pretty awesome. In this book by Mr. Roth, they put a picture to show you the difference in the number of parts between a 2-cycle and a 4-cycle. And so there you can easily see that there is no camshaft over here. But they didn't show the valves and the valve springs and the lifters and tappets and all that here. I don't know why they didn't show that, but anyway, you can see that there's a lot fewer parts in a 2-cycle engine. This page is directly out of a Goodhart-Wilcox book from 1956 called All About Small Gas Engines, written by Judd Purvis. So I'm giving him credit for that. But here in these 4 pictures here are what's happening inside of a 2-cycle engine, and it's all happening within 1 revolution. Remember, there's a power stroke every revolution. And they call the valves leaf valves. I call them reed valves. But in picture A, the compressing charge in the cylinder is sucking fresh charge from the carburetor into the crankcase. So we got gas and air coming in into the crankcase with the valve open. And in the next one, as the piston is all the way up, it's firing that charge in the cylinder, so that's the power stroke, and the leaf is still open there. And here in number C, the leaf is closed and expansion in the cylinder's compression in the crankcase. So down goes the piston, and at the same time it's compressing the fuel that's down here. And in D, when it's all the way down, the exhausting burned gases are transferring, stop. This page is taken directly from a book by Goodhart-Wilcox called All About Small Gas Engines by Judd Purvis from 1956. But in these 4 pictures here, it shows you pretty much what's going on in a 2-cycle engine. Remember that there's a power stroke with every revolution, and they are calling these valves leaf valves, and I guess that's a good term, but I always call them reed valves. But in the first picture here, A, the compressing charge in the cylinder is sucking fresh gas from the carburetor into the crankcase. So as the piston goes up, a vacuum is formed and it's sucking the gas fuel mixture in. And that's with the valve open. And in B, that's the firing charge in the cylinder. So the leaf is still open and the piston is all the way at the top dead center. And then right here, C, there's an expansion in the cylinder as it fires, and piston is moving down, causing compression in the crankcase with the valve closed. And finally in D, with the valve closed, exhausting burn gases. So the gases are going, the used gases are going out the muffler, out that port and out the muffler. And at the same time, that fresh charge is coming in through the transfer port. You see the little arrows there. And it's pushing the exhaust out. And that's the purpose of the dome on the piston, to deflect that charge. The problem with a 2-cycle engine is that there's also some fresh charge and raw gasoline escaping, which is inefficient and causes pollution. And that's what's happening inside of a two-cycle engine in one revolution. Now let's have another look at the cycles. Remember, two-cycle just means that it's the piston going up and the piston going back. And as I sawed this out, which was no easy job, realized that there's a steel liner in there. A lot of them use a sleeve or a liner. And you can see there's just an awful lot of scoring there. And with the headless design, it was difficult to remove the carbon from the top because you didn't have a head you could just take off, but that has built up quite a bit. You can see how deep the cooling fins are and incredibly effective. I did not put the rings back in because I didn't want to, well, I wanted to make it easy on myself. So I've cut that much away so you can see the piston moving up and down. So now let's see if I can explain this the way it was explained in the book. In a two-cycle engine, the piston moving back and forth in the cylinder and covering and uncovering the ports is what acts like the valves. And looking at it from the input side here, where you can see my little punch moving in and out, and that is coming from the transfer passage in the crankcase, and that's where the fuel will enter the cylinder. When it does, it is deflected up and puts the charge toward the spark plug and drives the exhaust out. And now I've got the punch in the exhaust port here, if I can. Remember, one of them is still clogged. I didn't even bother to clean it. Perhaps you can see now the punch coming in there, and that's where the exhaust is going. Remember, that's called cross-scavenging, as the gases come in and drive the exhaust gases out. And here's what happens. As the piston moves up, it's doing two things. It's compressing the charge that was already in here, like that. And at the same time, a vacuum was formed in the crankcase and it drew in some of the fuel mixture. And when it comes to top dead center or thereabouts, we have a spark, we have ignition, we have power, and the piston is driven down. Now, as it is driven down, it is compressing somewhat the charge that's in the crankcase, so that on the next stroke, that is pressurized and can find its way back into the cylinder. Remember, at the moment, both ports are closed. And as it goes back, and it's at the bottom, this port is opened, in rushes that fuel mixture, it's deflected by that domed head there and forced up into this area, and in the meanwhile, it's directing the exhaust gas back out through the muffler. But as that happens, we're losing some of the good fuel charge at the same time. That causes pollution. And that's happening very rapidly, possibly at 8,000 times per minute. Always use fresh fuel. Empty the gas tank out and the carburetor out, bleed it out or run it out at the end of every season so you don't have old fuel in there. It'll cause you nothing but problems. Most of the problems are caused by spoiled fuel in all engines. And that concludes this video on the two-cycle engine. I hope you enjoyed it. I hope it made sense to you. This is tubalcain saying so long for now.